Hi, I'm Jose Conchello, and welcome to TuneCraft. I designed and developed TuneCraft as my final project for the Wearable Devices and Computer Vision class here at the Harvard Extension School's Digital Media Design graduate program. TuneCraft is a creative technology project that integrates 6D object pose estimation with dynamic audio control for immersive and interactive digital art installations. The TuneCraft project explores advancements in the realm of digital art and interactive media, leveraging the potential of 6D object tracking and real-time pose estimation. At its core, the project utilizes MediaPipe for real-time pose estimation to interpret spatial positioning of objects within an environment. This technology is integrated with Touch Designer and Ableton Live to create a platform for interactive and immersive experiences. TuneCraft's goal is to break away from the traditional boundaries of user interaction in digital spaces. By allowing real-time manipulation of audio outputs through physical movements and object positioning, the project aims to blur the lines between digital and physical, offering novel user interactions. This project highlights the innovative use of technology in art. It showcases how tools like MediaPipe, Touch Designer, and Ableton Live can be combined to create engaging experiences. Some of the key results of this project are that we achieved good success in enhancing user interaction with digital art, primarily through the integration of real-time object tracking and user feedback. The major achievement in TuneCraft is its an integration of 6D object tracking within Touch Designer, enabling real-time music manipulation for more engaging user experiences. Some of the key features of TuneCraft are that it enhances the user experience through hands-on interaction and leads to a more intuitive and enriched audiovisual journey. MediaPipe's Objectron was a crucial piece in providing precise real-time object pose estimation, which was a cornerstone in the interactivity and responsiveness of the project. Some limitations of the project include the small range of objects able to be detected by MediaPipe, as well as the performance lag due to limited compute power while running multiple compute-intensive programs at once. Lastly, this project serves as a proof of concept for future projects in the realm of interactive installations, demonstrating the potential and feasibility of similar computer vision-driven projects. The, the TuneCraft architecture is centered around Touch Designer, which acts as the main interactive platform, integrating real-time visual data processed by MediaPipe by routing video data feed to different work pipelines. At the heart of this project is Google's MediaPipe, an open source framework for our computer vision inference. Within MediaPipe, we utilize Objectron for its specialized capabilities in 6D object pose estimation. This tool allows us to track the real-time position and orientation of objects. MediaPipe Objectron is a mobile real-time 3D object detection solution for everyday objects. It detects objects in 2D images and estimates their poses through machine learning models trained on the Objectron dataset. Object detection is an extensively studied computer vision problem, but most of the research has focused on 2D object detection, while 2D predictions only provide 2D bounding boxes. By extending predictions to 3D, you can capture an object's size, position, and orientation in the world, leading to a variety of applications in robotics, self-driving vehicles, image retrieval, and augmented reality. Although 2D object detection is relatively mature and has been widely used in the industry, 3D object detection from 2D imagery is a challenging problem due to the lack of data as well as the diversity of appearances and shapes of objects within a category. The Objectron dataset is a collection of short, object-centric video clips which are accompanied by AR session metadata that includes camera poses, sparse point clouds, and characterization of the planar surfaces in the surrounding environment. In each video, the camera moves around the object, capturing it from different angles. The data also contains manually annotated 3D bounding boxes for each object, which describes the object's position, orientation, and dimensions. The dataset contains 15,000 annotated video clips supplemented with over 4 million annotated images in the following categories: bikes, books, bottles, cameras, cereal boxes, chairs, cups, laptops, and shoes. Along with the dataset, MediaPipe also shares a 3D object detection solution for 4 categories of objects: shoes, chairs, mugs, and cameras. These models are trained using this dataset and are what we will use to get this project bootstrapped. Here, computer vision is used to elevate the capabilities of interactive media. By integrating computer vision techniques within Touch Designer, we've opened new avenues for creating interactive media applications. This combination allows for more active audience engagement and installations via interactive dynamic environments. Touch Designer is a visual programming environment for creating interactive applications, installations, and multimedia content. It's not just about visualizing data. Touch Designer also processes live data and is fully compatible with Python, allowing us to execute custom scripts and automate processes. This versatility makes it an ideal tool for developing real-time interactive and immersive applications. Next, Ableton Live is a versatile digital audio workspace, also known as a DAW. It excels in loop-based compositions, live performances, and real-time synthesis. This makes Ableton Live the ideal tool for creating real-time interactive soundscapes. Additionally, the integration between Touch Designer and Ableton Live is quite good. There's the TD Ableton package, which links programming with audio manipulation, facilitating control over Ableton's music parameters driven by real-time data. This, in turn, allows for synchronization of sound with visual elements for a more immersive AV experience. Some previous work in this space include several known projects and entities. First, we have their React Table Live, which is an innovative electronic music instrument with a tangible user surface, which allows musicians to create and manipulate music through physical interaction with a luminous tabletop surface. Another one is Moment Factory. Moment Factory is a multimedia entertainment studio specializing in the creation of immersive environments, large-scale installations, and interactive experiences that combine video, lighting, architecture, and sound. And then lastly, we have Art Tech House. Art Tech House is an innovative art space that combines art, science, and technology to create immersive and interactive digital art exhibits and experiences. Next, we have methodologies of how we set up this project. First, we use Anaconda to manage project dependencies such as OpenCV, MediaPipe, and Python versioning. Then we have a configuration script set to set the system paths for Touch Designer to utilize external libraries like OpenCV and MediaPipe. Next, we have our video processing and object detection pipelines. We use a USB web camera mounted on top of a projector to capture our video. This video is routed to Touch Designer's video device in operator. Then that video stream is routed for our AR-UCO marker detection pipeline and our 3D object detection pipeline. OpenCV's AR-UCO tools are used to establish the projector's boundaries relative to the video feed. Using the AR-UCO markers, the video is then cropped to fill the camera, then rescaled to optimize for the object detection pipeline. That feed is then fed to MediaPipe to get the X and Y position of the objects and the X, Y, and Z rotation in real time. Next, that data is routed for UI and Ableton pipelines. For the UI pipeline, the positional data is represented as a projected spotlight tracking the object, while the rotational data is represented by concentric arcs for X, Y, and Z rotation. For the Ableton pipeline, we remap the 6D object detection values to correspond with the Ableton Live's parameter ranges, including the speed of the percussion and the harmonic keys of the melody and other filtering parameters. Okay, let's take TuneCraft for a drive now. The application starts with no object detected because, of course, it's not detecting any object. But as soon as we throw the shoe in there, it'll start detecting something and magic will start happening. As we move the shoe along the X-plane, we'll notice a change in the drum patterns that are happening, and you can also see that in the upper left-hand corner in the Ableton. You'll see in the teal section, the marker will move as we move the shoe from left to right. And as we move this shoe up and down on the Y-axis, that'll change the instrument that is playing. And as I rotate the shoe, you can see that in the blue column, the track that is playing changes, and in the black box, the little orange icon moves to signify change in rotation. Now if I remove the shoe from the camera's view, you'll see that the no object detected screen comes on. And then once I put the shoe back in, the song immediately starts again. As a final thought, I think that MediaPipe has the potential to reimagine how we interact with space, but for more precision-based applications, I think MediaPipe still has a long way to go, especially with rotational data. And that's it, and thank you for joining me on this musical computer vision-driven journey. So, in summary, TuneCraft merges computer vision with interactive audio control in an interactive setting. It employs Touch Designer, Ableton, and MediaPipe for unique audio-visual interfaces. In doing so, it demonstrates the potential for computer vision in enhancing real-time user interaction. It also provides a dynamic multisensory experience by translating physical motion into auditory and visual changes. TuneCraft serves as a new ecosystem for creative and technological pursuits in the realm of interactive media for the future. Thank you, and that is all.